This is question 11 of the 2024 O-Level A Math Paper 1. So we have a diagram here, and we're supposed to show that the length cm can be expressed as 2 cosine theta plus 3 sine theta. So first of all, let me just highlight the length that they want us to express as that expression, so that is cm. So I'm going to draw some lines to help us visualize how this length can be broken down into some parts that we can find individually first. Okay, so I'm going to form some triangles, specifically right angle triangles. Okay, and let's call this point X. Okay, we can see that CM is the sum of CX and XM, right? So if we can find CX and XM, we can find CM. So CX is, if we use theta of the triangle CXB as a reference angle, then CX is the adjacent, BX is the opposite. So do you see that cosine theta is equal to CX? Okay, adjacent over hypotenuse, so that is CX over 2. Okay, BC is the hypotenuse. So CX is equal to 2 cosine theta. Then, looking at triangle, I'll call this point Y. So looking at triangle ABY, now if we want to find XM, XM is equal to BY, right? So we can find BY first. So we can try to form a similar trigonometric expression involving BY. So sine theta in the triangle BAY, okay, is equal to the opposite over the hypotenuse. So BY over 3. Which means BY, or rather XM. Okay, so XM is equal to BY, which is equal to 3 sine theta. So CM is the sum of the two expressions we just found, plus 3 sine theta. Okay, and that will be the solution. Let's take a look at part B. By expressing 2 cosine theta plus 3 sine theta in the form r cosine theta minus alpha, find the maximum possible length of CM. Okay, so here we have to use the R formula. Okay, so basically for the R formula, you need to know how to find R and how to find alpha. So R in this case will be equal to square root. Okay, we look at this 2 and this 3. Square root of 2 squared plus 3 squared, which is equal to square root 13. Okay, and alpha is equal to tangent inverse 3 over 2. Okay, so again, looking at the 3 and the 2 here. And if you put that into your calculator, you should get 56.310 degrees. Okay. So therefore, 2 cosine theta plus 3 sine theta is equal to square root 13 times cosine theta minus 56.3 degrees. I'm just going to leave it to 1 dp because this is the final answer, and find the maximum possible length of CM. Okay, so this expression is basically the length of CM, right? Okay. And you know that any cosine function, so cosine of anything, has a maximum value of 1. So square root 13 times cosine something will have a maximum value of square root 13. Okay. So therefore, maximum length of CM is just square root 13. Okay, which is 3.606, or to 3SF, it's 3.61. All right, now for part C, find the value of theta for which Cm is equal to 3.5. So that expression, where we applied the R formula, we're going to equate it to 3.5. And that's going to be the trigo equation that we solve. So this is equal to 3.5. So we're going to find the basic angle of not theta, but of theta minus 56.3 degrees. Okay, that will be cosine inverse 3.5 over square root 13. That is 13.898 degrees. Okay, this is just the basic angle. So we look at the ASTC diagram. So here we have a cosine function and it was positive, right? So we will look at the first and the last quadrant. Okay. Also take note that because theta is acute, which we already see from we can see from the diagram. So theta is between 0 to 90 degrees, which means theta minus 56.3 degrees will be between negative 56.3 degrees and 90 minus 56.3 degrees, okay, which is 33.7. So if we look at the first and last quadrant, we can see that in the first quadrant, the angle itself can be 13.898 degrees. Okay, so theta minus 56.3 degrees can be either 13.898 degrees or if it's in the fourth quadrant, it can be also negative 13.898 degrees, right? Okay, so these are the only two possible values that lie within the range of theta minus 56.3 degrees. Okay, so if you want to find the actual theta value, you just add 56.3 degrees to those two values. So you'll find that theta is equal to 70.2 degrees or 42.4 degrees. So those are the solutions for part C.